Good afternoon, everyone. This is Sadia Zafar from HRAI. I would like to welcome you to today's session. Our presenters, Karl Fernandes, Product Manager, and Ron Vanhevel, Technical Services Manager, both from Rheem, will take you through a discussion on heat pumps versus air conditioner and answer all your questions on this topic. A little bit of housekeeping, you will notice on the control panel of your screen the Q&A feature. Please use the Q&A feature to ask your questions at any time during the webinar. They will be addressed at the end of the session. Also note this webinar is being recorded and the recording will be sent to you following the session. Now we welcome Karl. Karl, if you could unmute yourself.
My apologies. Unmute yourself, the word of 2021 and 2020. Thanks, Sadia. Good afternoon, everyone. And Ron and I appreciate everyone taking the time out of your busy schedules, especially during your lunch hour. Today, we are covering heat pump versus air conditioner. I will cover the features of the Rheem systems, and Ron will be covering the installation and application. When choosing between an AC versus heat pump, which one is the best solution? These units from the outside look virtually the same, as you can see from the pictures. They both use refrigerant to transfer heat from inside to outside, which is accomplished by the absorption and rejection of heat through the refrigerant circuit. The internal parts are essentially the same, except for some extra components in the heat pump, which includes a reversing valve, an outdoor TXV, or EEV. We will cover these components along with the control boards later in the presentation. Previously, heat pumps were installed with air handlers, and air conditioners were mainly paired with gas furnaces. This was quite traditional. The reason for this cost was simply driven by an air conditioner and a gas furnace were more expensive than an air handler. In the past, heat pumps required auxiliary heat as the temperatures dropped, and this will be covered later in the presentation as well. With new inverter technology and systems being able to operate in overdrive, this is not the case anymore. As we strive for higher energy efficient systems such as RP17 and RP20, we find owners are looking for dual fuel systems, which incorporate both gas furnaces and heat pump versus just a standard air handler.
Rheem, North America's only manufacturer of heating, cooling, water heating, and commercial refrigeration solutions, has been an industry pioneer, responsible for developing many first-of-all products that have changed the way contractors design cooling platform has game-changing features, unlike anything else available today.
Karl, the sound is cutting out. I'm just wondering if we can sort of move to the next session.
Okay.
Did you share your computer sound or no? That's probably what it is.
I did.
Yeah, it's okay. But yeah, you can certainly go on. Yeah,
yes.
It's okay.
Thanks, Loretta.
No problem.
It's hard these days, especially with everybody and the bandwidth, and everybody's Wi-Fi is different. But you get the gist. I will get through, these are the product tiers. You have Classic and Classic Plus and Prestige, and our platform ranges from RP14 to RP20. And on the AC side, it's RA13 to RA20. The Prestige Air 20 SEER air conditioners and 20 SEER heat pumps with up to 11 HSPF, heating seasonal performance factor, with AHRI matchups, which meet cold climate listed for the federal greener home rebates. So there's about 5,000 in rebates potentially. The RA20 and the RP20 are Econet enabled, allowing advanced air and water control for maximum energy savings and ideal comfort. And when we say water control, Rheem is one of the only manufacturers that produces air and water products. And we provide that feature of EcoNet enabled on both sides of the company. Feature highlights are numerous for both the AC and heat pump, starting with a number of features also found on the other tiers of HVAC outdoor residential units we offer in Classic Plus and Classic tiers. Variable speed operation, inverter scroll compressor, EcoNet enabled, EcoNet zoning enabled, modern cabinet aesthetics, composite base pan, composite optimized fan opening, swept wing fan, optimized reversing valve, electronic expansion valve on 20 SEER units, integrated service trays, 15-inch wide control box, easy handling, 35% less fasteners, integrated lift receptacles, external gauge ports, diagnostic window, QR code for relevant installer tech literature and support, easy disassembly and reassembly, and a 10-year warranty for unit replacement when registered. The nomenclature for our products is very easy to understand. The only difference between the AC and heat pump is the second letter A for AC and P for heat pump. The EcoNet thermostat is the command center for compatible Rheem HVAC and water heating products. Features include compatible with all EcoNet enabled products. On the Proterra we feature in our last HRI webinar, for example, built-in Wi-Fi, one-touch energy savings, weather when connected to the internet or local temperature when connected to communicating outdoor piece of equipment, built with premium materials, ultra-thin design, automatically wakes when you approach, streamlined and intuitive, ability to connect to wired thermostat, and tool-free wiring. Let's look at the location of different items on the home screen. Top center weather when connected to the internet. Top left brand logo, Rheem or Rude. Just below the weather icon is the messaging bar. One touch away button. In the center of the circle is the room temperature. Bottom left corner is the menu button. Bottom center is the set point red for heating and blue for cooling. If you have an auto mode, will show both red and blue. System mode. Plus and minus for temperature adjustment. And next we have the motion sensor, humidity level, Wi-Fi symbol when connected, and finally alert symbol if issue with the system. Rheem has partnered with Amazon, and Alexa makes changing the temperature easy with voice recognition. Just some of the terms that we will cover: seasonal energy efficiency ratio, which ACs and heat pumps are measured. SEER determines expected energy efficiency for the whole season. So the efficiency of the AC is measured at air temperatures from 65 Fahrenheit to 104 Fahrenheit. This also accounts for the stopping and starting of the unit. Heat pumps are rated by heating seasonal performance factor when in heating mode, and 8.5 today earns you an Energy Star rating. When heat pumps are operated in cooling mode, the unit's efficiency is rated by SEER. The higher the ratings, the greater the savings. 30 plus features to our cooling platform over our previous generation. +1 energy efficiency, which means 20 SEER through 5 tons, and HSPF of 11 through 5 tons, composite base fan, optimized fan orifices, louvered coil protection, and some of the other features we've discussed. 360 installability. So expanded valve space, 15-inch control box, high-low voltage hookup and external gauge ports, integrated lift receptacles, and no sharp edges. +1 triple service access, which means better access for the installer, corner service access, diagnostic service, QR codes, smart component placement, 35% less fasters, and some of the other features which are beneficial for the installer. +1 communication, which is intuitive programming, system-wide Wi-Fi, mobile apps and website, and simple wiring and 4 to 3 setup, self-configure in 30 seconds, and auto airflow optimization, and dual fuel ready, which we discussed earlier. Complete diagnostics and system accessory management. I will now pass the presentation to Ron Vanhevel, our technical service manager.
Give me a second here. I'm kind of grabbing the screen and I'll be right there. Okay, I got a low bandwidth. I have to apologize for my internet, so I'm going to turn off my video so you don't, you're not going to be able to see me, just for the simple reason due to the low bandwidth, but I will on now without video. Okay, let's look at applications and installation. This includes everything from choosing a location, proper tools and refrigerant, replacement units, indoor coil, interconnecting tubing. So choosing a location is important to keep refrigerant tubing and wire as short as possible. Locate the unit so water runoff will not create issues. Locate unit away from the drip edge of the roof. This is especially important with heat pump because large amounts of water entering the unit or snow entering the unit can impact blade and motor life. If water cannot drain away in freezing conditions, this will affect the unit operation as well. Clearances, 6 inches minimum. We do recommend 12 inches to the sides of the grills. You want 24 inches service access and a minimum of 60 inches to the top of the unit. Remember, this is a heat pump, so it must be raised off the ground for proper drainage. Frequent washing of the cabinet with fresh water will remove most contaminants. If you're using a more aggressive cleaner, ensure to rinse thoroughly. Provide some additional protection. Also, do not forget to take into consideration social gatherings in the backyard or sleeping areas of the home, even as the decibel levels of units are decreasing. So now let's look at tools, refrigerants required. Manifold set, rated for 800 PSIG, properly maintained. There are many brands and varieties available through your local distributor. Recovery cylinders, rated for 400 PSIG. And these are required to reclaim the refrigerants. As we all know, it is illegal to release refrigerant to the atmosphere. Appropriate refrigerant as specified on the unit rating plate. At this time, we're using 410A, but this will change going forward. So we want to make sure that we know what refrigerant is in the system and we have the proper tools. Vacuum pump. Vacuum pump to remove moisture, air, and non-condensables from the refrigeration system. Properly maintained vacuum pump, like I said, we also need a micron gauge. Micron gauge is to verify the system is properly evacuated. For the best reading on the system, the micron gauge should be located at the furthest point from the vacuum pump. And did you know at sea level, you have 760,000 microns. So you have to have a micron gauge. You cannot do it with the gauges alone. There's new gauges out there that may be able to register microns, but you have to know what the micron level is. We recommend to pull down to 500 microns, and it should hold for a minimum of 15 minutes. And let us not forget the reclaimer, which may be required to remove refrigerant from the system. As you know, the system compressor should never be used to pull a system down below 50 psig. Why, you ask? Well, as this may damage the compressor windings to electrical arcing if the system is going to be put back into service. Rheem case coils. Features multi-drain connections. As you see here, we have many connections. This is to make it easier for faster installations in the upflow, downflow, or horizontal position. Now let's look at refrigerant line sizing. But before we begin, we need to know why line sizing is so critical and the purpose of the suction and liquid line. So the liquid line is to transport a warm, self-cooled liquid to the metering device. In cooling mode, the metering device is located indoors. And in heating mode, the metering device is located outdoors. So this is one of the differences from a heat pump to an air conditioner. With an air conditioner, you're only going to have a metering device indoors. You're not going to have one in the outdoor unit. We need to properly size the lines. This is to reduce the possibility of flashing of refrigerant. This, however, can be caused by several reasons, including low charge, improperly sized lines, heat absorption along the line, and or excess vertical rise. We all know the maximum pressure drop allowed between the condenser and the evaporator is 50 psi. The suction line. The suction line is used to transport superheated vapor to the compressor. Suction line sizing is important for capacity as well as oil return to the compressor. But then we have the fittings. Each fitting used in the line connections have equivalent fitting lengths. These are associated with them and are added to your actual linear lengths. This will help to determine actual diameter of the refrigerant tubing required. So the actual length of the piping is used for rough charging purposes only. Also, when choosing lines for variable speed units, it is important to remember liquid lines are typically sized for full capacity of the unit. And suction lines are sized for minimum capacity. This is to keep pressure drop to a minimum, but maintain oil return when the unit is running on the lowest compressor speed. As we know with our systems, we do not require oil traps with R410A and POE oil. So our systems do not require oil traps as previously with R22. Somebody told me this was because mineral oil is lazy, whereas POE oil isn't. So it stays up with the refrigerant and due to the velocity. Okay, now that we know what the lines do, let's go through the steps to select the proper liquid line and suction line. So first of all, we got to pick the unit size. So here, what we're going to do is we're going to look at it and we're going to pick a 10.5 unit. So we have our 1.5 ton unit. We're then going to have to know what the equivalent length is. So in this case, what we've done, we've picked a 45-foot line set. So with a 45-foot line set, we're going to be in this area because the line set equivalent length is 26 to 50 feet. And in this situation, what we've done is we said, okay, we're going to do 3/8 and 3/4. There's an asterisk, and we're going to talk about why that asterisk is there. We go all the way across over to here. And we want to know what these numbers mean, 50 and 1. So what it means is if I use 3/8 and 3/4, I can do a 50-foot maximum vertical separation, and I will still be running at 100% capacity. But remember I was talking about that asterisk? Well, here it says, asterisk, 3/4 inch vapor line should only be used for 1.5 ton system if the outdoor unit below or same level as the indoor unit. Otherwise, you're going to go to 5/8. It always recommended for good oil return to always go with your smallest suction line available, as per the charts, not what's on your truck or what you're going to pick up, which is cheapest or most cost effective. So now let's look at what this means. We have used long line set guidelines for linear lengths greater than the shown below. So what this means is if you're using 1/4 inch and 5/8 and you're running more than 117 feet, we were now going to have to follow long line set guidelines, which means you may have to add some extra stuff as per the manual in these cases. So the thing to remember is line sizing charts for heat pumps and ACs are relatively the same. Every model and size of unit has its own line sizing charts. So it is imperative to follow the proper manufactured line sizing chart. Remember, when charging a system with a TXV or EEV, the final charging is calculated by subcooling. And with a piston coil, it is done by superheat. But also, our systems are all matched with TXVs, so must be charged based on subcooling. So let's look at the similarities and differences between wiring on an AC and a heat pump. When an AC, the wiring can be as simple as connecting to the Y and C on the outdoor unit, off the board to the outdoor unit. It can be as simple as connecting Y and C. With heat pumps, you have extra connections, which includes the ability to switch from heating to cooling, as well as defrost and auxiliary heat for defrost mode. So as you see here, you got a D, so this brings on your auxiliary backup heat when you're in defrost mode. Why, you ask? Well, if you don't have backup heat or auxiliary heat, we'll call it, then you're basically in air conditioning mode, so it gets cool in the house. So you want to put that on. With the communicating systems, then the new, more advanced systems with the Ethernet, the control wiring consists of only 4 wires. Yes, it's that simple. E1, E2, R, and C. From the communicating Ethernet thermostat to the outdoor unit. This doesn't matter if the system is a RA 17 or 20 air conditioner or an RP 17 or RP 20 heat pump. So it doesn't matter if heat pump or air conditioner, it's as simple to wire both. Also, all Rheem and all Rude heat pumps, when it de-energized, are in the cooling mode. That's right, we're in the cooling mode when we're de-energized, whereas other manufacturers, when de-energized, are in the heating mode. So what's this mean, you ask? Well, this means you need to ensure you are connected to the B terminal, not the O terminal, if you're using a legacy thermostat. And that's a standard 24-volt thermostat. So Depending on whose thermostat, if you're using a generic RAM one, then they'll have B and O terminals. So you have to remember that you're connected to the B terminal when you're hooking up to a Rheem or Rude product. If you inadvertently connect to the O terminal on the thermostat, what will happen is when you set the unit to cooling, you'll actually be in heating mode. So if you're on a system, you got it in cooling and it's in heating, look at those terminals, you're probably hooked up to the O terminal, right? So let's look at the top view of an AC. So this is the top view of a standard AC. Components may not be quite as depicted in here, depending on the model of the unit. But notice the complete corner panel can be removed for easy access. So this doesn't matter if it's an AC or a heat pump. You can get at all of your stuff here. There's your full panel that can come off on the unit. Inverter AC or heat pump coming away. So even though the AC and heat pump units both come as inverter systems, the controls are more complex for the heat pumps. So as you see here on the left, we got a little board here for the AC system. Still have your dual run capacitor and 24-volt contactor. But now when you get into the heat pump systems, it's more complex. It now has a variable speed outdoor board for the fan, and then your main control board. So as we said, controls for ACs versus heat pump. An AC may have something as simple as a standalone contactor to power the outdoor unit. Whereas heat pumps, entry-level heat pumps, may incorporate a basic defrost control board with simple flashing LED red lights. These can indicate operation and or troubleshooting. As you'll notice, it's for serviceability, the LEDs has a light up a board right on here to tell you what the LED lights mean. Well, now if I go into a board, whereas a inverter products, like I said, more complex, may be used, it doesn't matter which system is being installed. We offer training for them all. And the board has a dual 7-segment display here. The display gives you display status, diagnostic codes, fault recall, compressor speed, superheat, and defrost menus to assist the technician on site. Having a 7-segment LED, dual 7-segment, this reduces the time and the possibility of misinterpreting fault codes with flashing LED lights alone. There is, however, LEDs to show if the power is present. So as you can see here, power LED, so there is a red light, so that at least you know that you have power there if you don't have the multimeter on you at that point. As well, the operation of the electronic expansion valve. So we have a green light. So if it's solid green, means the expansion valve, electronic expansion valve is fully open. If it's flashing green, it means it's opening. We have a red. Solid red means the electronic expansion valve is closed. If it's flashing red, it means it is in the process of closing. So without even having tools, you get a lot of information. As you see, everything is well labeled on it. I'm not going to go through everything, but everything is well labeled on here where everything goes. So let's move on now. Let's look at defrost. So defrost is a cycle which is required for heat pumps. Yes, this may not be what units look like. First thing you see here is when you look at it, you go, wow, who installed that, right? Because it's not installed above grade. And that's one thing that you have to look at when you're installing a heat pump versus an AC. You have to make sure it's raised off the ground for proper water drainage in defrost mode. So 3 things are required to initiate defrost. The outdoor temperature must be below 35 degrees. The compressor must have operated for 34 minutes without outdoor air temperature below 35 degrees. The temperature differential between the outdoor temperature and the condenser coil temperature must exceed the board algorithm. Also for defrost, and again, different models operate a little different on defrost. I'm not saying all models are going to operate the same way. Again, we have training materials on all this, on how the unit's operating. So first on this one, the board will enter a 30-second time delay. This is called a noise abatement. So it just kind of, you're not switching automatically. And in this case, the outdoor fan and reversing valve will be de-energized. A 24-volt signal is then sent through the D terminal for auxiliary heat, if you have auxiliary heat. And as we talked about with the higher end units, more complex units, as they're able to go into overdrive, you may not be putting auxiliary heat. When the compressor is re-energized, the system will start in defrost mode, which is basically cooling mode with the outdoor fan turned off, right? You're just redirecting the heat to the outdoor cold unit, shutting off the fan so it defrosts that coil. That's another difference between an AC and a heat pump, right? So there's only a few differences. It's not really complex. People get afraid when they, oh, I got to work on a heat pump. Nah, it's basically the same. All you've done is flipped your coil from inside to outside for heating and cooling. So the hot gases are redirected to the outdoor unit to defrost the condenser coil, as I said. The defrost will terminate at 14 minutes. Again, 14 minutes, or after the outdoor coil has reached the predetermined settings as per the dip switches. From the factory, it's at 70 degrees Fahrenheit, but it can be 60, it can be 80, depending on your location. Most people leave it at 70 just because it seems to work there. There is a predetermined delay before the compressor is re-energized in heating mode as well. So that's defrost, which is something that you have on air conditioning, heat pumps, sorry, but you don't have on air conditioning. So now let's look at the sensors. Control board uses two sensors: a coil sensor, the outdoor temperature in the coil, and an outdoor ambient temperature sensor. Both these sensors assist in the defrost process for the defrost. On your higher end units, you're going to have, there's 4 sensors in the outdoor unit. There's a sump sensor on the bottom of your compressor. There's coil sensor, there's more sensors, right? So there, again, it's more complicated than it is on a simple system. So as I said, these sensors are negative temperature coefficient type thermistor, which means the resistance lowers as the temperature increases. So as you see here at -10, let's pick for instance, that's 55,000 approximately. If you go to -20, now the resistance is 96,000 ohms resistance. You need to have a good multimeter. If a technician goes, they need to have a good meter to read it. Thing to remember is these sensors have 4.5 to 5 volts DC sent to them. So if the sensor checks out, you're going to want to make sure that you have that voltage present. And again, that's DC voltage, not AC. So let's look at high and low pressure switches. High and low pressure switches may be present on the AC units, but are not required. But they are required for heat pumps. We do require high and low pressure switches. The high pressure switch, 610 PSI, and closes at 420. And the high pressure switch can open due to an inoperable fan, an overcharged system, and dirty outdoor coil. The dirty outdoor coil is something that sometimes gets missed. People look at the coil and they go, yeah, you know what? That coil is clean. You cannot tell me a coil is clean unless you just washed it. If you have a high pressure issue, you want to wash that coil, right? And if you're using a cleaner, make sure you rinse that cleaner off. The low pressure switch opens at 15 PSI and recloses at approximately 40 PSI. So this is basically a loss of charge. If you've lost down to 15 PSI, you've basically a loss of charge. If either switch opens 3 times during operation, the system will lock out and an error code will be displayed on the control board. Muffler. Again, mufflers, you don't see them on ACs. They are used to remove both low and high frequency pulsations. and they are located on the discharge line of the compressor on heat pumps. Thing to remember here is after time, you may not be able to read what's on there. Don't make the mistake of thinking that's a liquid line dryer. If you do, you're going to find out really quickly why it should have been a muffler and not a liquid line dryer. So now let's look at reversing valves. Again, this is a component that's not used in an air conditioner. Why do we need a reversing valve? Well, reversing valves are used in heat pumps to redirect the flow of refrigerant for the heating and cooling modes. So as you can see here, this one is in cooling mode when it's de-energized, right? As we said, our systems are de-energized in cooling mode. Why? Well, you can put strip heat on if you need heating in the winter, but there's no way if a reversing valve stuck when you go to move it, can you put any type of cooling in your house? So that's why we fail to cooling mode. So in this situation, as you see here, the bottom tube is your high pressure tube. It's always high pressure, and it redirects discharge gases to the outdoor unit. We have your suction tube. Again, the center tube is your true suction. It is always suction. And it brings, not to the indoor coil, from the indoor coil, it will bring it back to your compressor. So what happens? Well, when we go into heating mode, all that happens is that we now redirect to the high pressure, high temperature, to the indoor coil. And we now suck vapors from the outdoor coil back to the true suction line to the compressor. So that's all there is difference, redirecting where we put hot and the cold. This is an actual view of one. So again, you can see what it looks like. Charge compensator. So charge compensator you may or may not have seen. This is basically a storage tank used for charge and balance from heating and cooling modes. So yes, you guessed it. It is not used in an air conditioner. It is only used in heat pump, in certain models may require. So what does this mean? The indoor coil and outdoor coil may have not been the same size, right? So sometimes you may not have the same size coil indoor and outdoors. So in some instances, you may have extra refrigerant, which is not required in the system, and it is stored in the charge compensator. So let's look at different locations for the installation of the charge compensator. Charge compensator may be installed in the vapor line between the indoor coil and the reversing valve. So here we have your reversing valve, and here's the tank. I'm going to go to your coil. Also has another line that hooks into your liquid line. So the compensator may be installed here. So what happens when the reversing valve is connected to the liquid line via T? So when in cooling mode, the tank is cold. So extra refrigerant will migrate into the tank and be stored in this instance. In heating mode, the tank is hot. Right? So we go this way. So on this system, the tank is now hot. So in heating mode, we put that extra refrigerant that was stored in that tank, and it migrates back into the system, and we don't keep anything there. So this is engineering due to sizing of coils. This doesn't mean you can mismatch systems. This is just an engineered system way of doing it. But we're not done there yet. They're not always located between the reversing valve and the indoor coil. We can also locate them between the outdoor coil and the reversing valve. So notice the refrigerant is now stored in the compensator in the cooling mode. So in cooling mode on this one now, the tank is hot, right? Or defrost mode. And in heating mode, the tank is now cold. So as we said, remember, the charge compensator is not required for an air conditioner, as the refrigerant only flows in one direction. Outdoor metering device. So again, another component that's not required on an AC is a metering device in the outdoor unit. As the picture shows here, this is a TXV. On some of your communicating systems, you may have an EEV or an EXV, which is electronic expansion valve. The thermal expansion valve is designed to maintain approximately 5 to 15 degrees or 10 to 15 degrees superheat. Whereas with inverter products and the use of an EEV, we can have superheat as low as 6 degrees Fahrenheit, right? Because as we know, superheat is a necessary evil. We need superheat. Why? Well, because we want to ensure we have 100% vapor. If you have no superheat, you can't guarantee that you're sending vapor to the compressor. And we know what happens when you send liquid to compressors. They don't like it. Doesn't matter if it's a scroll or what type of compressor, it does not like liquid. So now let's look at the service valves. So the connection point for liquid and suction lines. The liquid line requires, after you remove a cap, needs a 3/16 Allen wrench to remove or open the valve. The big thing is to make sure you have the proper wrench. Some people are using sockets and they're not long enough, so you can end up stripping the valve. So make sure you have the proper Allen wrench. It's deep enough to reach to the bottom of the valve itself. For the suction one, it takes a 5/16 Allen wrench. But also notice on here, we have this extra port. What is this extra port? Well, that's your true suction line. Again, this is only required on heat pumps. You have to hook up here for your true suction. If you hook up to here and here, when you're in heat pump mode or heating mode on the heat pump, you will find they're going to read the same. And we've had that. You have to make sure you hook up to true suction. And we've made it easy for you. We put it outside the unit so you're not having to take off a cover to get back into the compressor where there's a true suction line. Filter dryer. Yes, filter dryers. We know filter dryers are used for both heating and cooling, right? So they're for heat pumps and air conditioners. Also, we got to remember when installing the filter dryer, you always install it in the coolest area. Why? Well, this helps ensure the dryer holds the greatest amount of water. Heat pumps also require a biflow, so it has an arrow on it. The filter dryer must go both ways. If you can't put a single direction filter dryer, whereas air conditioners only require a single flow filter dryer. It is also good practice when replacing a filter dryer to cut out the old one versus unsweating it. Why? Well, if you unsweat it, it's going to release moisture and contaminants back into the system possibly. I know we're all using nitrogen, but it's still better to cut it out versus unsweating it. So matching the coils. This is the last item. Coils must be properly matched to ensure proper heat transfer capabilities. Improperly matched coil can cause abnormal heat transfer, pressure switch trips, and capacity issues. And finally, compressor failure. Approved matches can be found on the Rheem spec sheet and on the HRI website. Stop. Must be match system or it's going to affect your warranty. Well, thank you, HRI. Thank you, Loretta and Sadia. We do appreciate it. And everyone else who attended, we do appreciate you taking time out of your busy schedules to join us. I am now going to stop sharing and we'll unmute everyone. And anybody that has any questions, if we weren't able to answer them, we'll answer them now.
Okay, that's wonderful. I have a couple of questions here for you, Ron. Does Rheem offer a hydronic air handler that is EcoNet enabled?
This one I'll take, Ron. We do not at this time because it's used primarily with our gas tankless, so maybe in the future.
Okay. I have another one here for reversing valve. I thought it was opposite Rheem fails to heating mode. not quite sure what that means. Maybe it's a little cryptic.
Okay, yes, no, all Rheem products all fail to cooling mode. Everybody else has failed to heating, which means that in the de-energized position, ours is in cooling mode, not heating.
Okay, I have another one here. What is the minimum outside temperature range for for a heat pump during wintertime without affecting unit efficiency?
That is a very good question, because different models operate at down different temperatures. People also look at what their hydro rates are. So if we got higher hydro rates, or if you're doing it with a gas furnace backup, those are all things you're going to take into consideration when you're deciding when you're going to switch over. A lot of people in Canada tend to switch over off heat pump at around 0 degrees Fahrenheit, I'm going to say.
Okay. There's one other question. I don't know if it was answered, but does Rheem use demand for, defrost or just the time temp?
It has, on some of the units, it's both. So it's on demand on the higher end units, but on the other ones, it's an algorithm also. So you can also, so I'm going to say it's both on some certain units.
Okay, that's wonderful. I have 2 more questions here. Again, it's a bit cryptic, so I hope you guys can figure it out. Line set size is same for AC and heat pump. I think it's asking.
Okay, so the easiest way to answer that is follow the chart. Your sizing is all based on what the chart says. The biggest thing to remember is that 5/8 will work on a lot of the systems, and you want the best oil return. So if you can go with a 5/8, you're better off with the 5/8. Also, with variable speed units, as we said, the
Your sound cut out.
liquid line is sized based on max capacity, and the suction line is based on oil return.
Okay.
I hope that answers the question.
Hope so too. I have one more question here. Where to get help to help you with troubleshooting, and how to troubleshoot newer thermostat and boards?
That's easy. You can call into our 1-800 number at Rheem, and we'll help you. You can also go to your local distributor where you get, and they will be more than happy to direct it to us.
Okay.
But we have a toll-free number. We have tech support in Canada, which I look after. So my team.
Okay.
So we're more than happy.
Okay, not a problem. This has been wonderful. I want to let everybody know that this is recorded, and we will be sharing this with everybody, and it will be up on our YouTube channel as well if you ever want to go back to it. A link will be sent out to you after the event. If everyone can please fill out the survey form when it gets sent to you, that helps us figure out what other topics we should bring to the table. Ron and Karl, I really, really do appreciate you taking the time to talk with us today and enlighten us about heat pumps and AC units. And do you have any final words, or just wondering before we shut it down? No?
Well, if you need further information, you can always go to our website, www.rheem.ca. So, and as Ron has said, the 1-800 number for technical on our units. So I'd just like to say thank you, Loretta and Sadia, and everyone who, the participants today, close to 70 people, which is fantastic. Thank you so much.
That's wonderful. Thank you so much, and have a great day, everyone.
Thank you.